Very good morning, students. Today we are going to discuss about basics of machine learning. So it's come under the subject of machine learning 21 CS 604, that subject code. So we will focus on what is machine learning and its various types. So let's see the next slide. So it's all about machine learning, right? So basically, machine learning in the sense, it's a branch of artificial intelligence and computer science that focus on the using data and algorithm to enable AI to imitate the way that humans learn, gradually improving its accuracy. That is what machine learning. So we'll see further. So basically, we should know what is learning. Then we'll go on what is machine learning. Then steps in machine learning, various types of machine learning, and finally we'll focus on applications of machine learning. These are the things we are going to discuss today. So let's start with learning. So why we are going for learning? Definitely in order to gain some knowledge, or we need to understand the scenario. That is what we are going for learning, right? So to gain knowledge or understanding of or skill in by studying or instruction or experience. So this is what learning means. Learning a set of new facts, learning how to do something, improving ability of something already learned. So if we are initially when we learn for driving, if we are very focused, right? In the sense we are, it's very difficult. We need to concentrate on both the sides, accelerator, clutch, etc., etc. When once you learn well, you will very smoothly you will travel, right? You will drive. So this is what. So learning by experience. So anyway, so gaining information or understanding the scenario or that is come under learning. What is machine learning? Machine learning is the study of methods for programming computers to learn. Building machines that automatically learn from experience. Machine learning usually refers to the changes in systems that perform tasks associated with artificial intelligence, that is AI. May include such as involve recognition, diagnosis, planning, robot control, prediction, etc. So we'll see further deeply by using this diagram what is machine learning. So definitely we are having a training data. So the training data is given as the input to the learning algorithm. So this learning algorithm in turn it's a trained machine and it's going to give the accurate or desired answer based on the query. So what are the steps in machine learning? So when we talk about machine learning, the steps are very important. So data collection, data representation, modeling, estimation, validation, apply learned model to new test data. So these are the steps we need to focus in the machine learning. So that is explained further in a diagram. So here the data actually given as the input to the learning process. Now this learning process in turn it will process the data and problem solving. There it will given as the input, pre-processed data, and we will do the performance evaluation. And if it is the input, we will give some teacher like or some instruction we are giving, and we will get the result. That is what we are doing it in the performance evaluation section. And if it is not satisfactory, we are giving the feedback back to the learning process. So it will drain the data further until we are getting the accuracy. This loop will continue. So this is the general structure of a learning system. So let us take, um, suppose a teacher is teaching something in the class and he is conducting quiz or something and the students are not at all performing well, what he will do? He will again teach the same concept, isn't it? In a more explainable way. Automatically he will conduct the test again, and if we are all succeed in the test means we will move on to the next topic, isn't it? So this is the general structure of learning system. We'll see the advantages of ML. Definitely solving vision problems through statistical inference. Intelligence from the common sense AI, reducing the constraints over time, achieving complete autonomy. So definitely when we do the things properly, we can it will lead to autonomicity. And when the manpower is reduced and everything is controlled by the machine, means it's lead to the error-free mechanism, right? So these are the advantages, but some disadvantages are also there. Definitely application-specific algorithm, right? So we can't have a common algorithm that can be applied to all the case scenarios. So real-world problem have too many variables and sensors might be too noisy. Then computational complexity definitely there. These are the disadvantages of machine learning. Okay. Then, now we'll focus on the various types of machine learning. So basically we can say unsupervised learning, semi-supervised or reinforcement learning, supervised learning. So we'll see one by one. Unsupervised learning, from the name itself, it studies how input patterns can be represented to reflect the statistical structure of the overall collection of input patterns. No outputs are used, unlike supervised learning or reinforcement learning. Here, no outputs are used. Learners is provided only unlabeled data. No feedback is provided from the environment. Okay, so there is no monitoring. It's just learn by themselves. Okay. Then main advantage is most of the laws of science were developed through unsupervised learning. The identification of the future itself is a complex problem in many situations. Yeah, because if there is no supervision, the learning initial stages are very complex. Semi-supervised or reinforcement learning, it is in between supervised and unsupervised learning technique. The amount of labeled and unlabeled data required for training, with the goal of reducing the amount of supervision required compared to supervised learning. At the same time, improving the results of unsupervised clustering to the expectation of the user. So here, what exactly we are saying is the middle between supervised and unsupervised. So in unsupervised, we are not having any control, right? But here we are having a labeled data as well as unlabeled data also. So somewhat we are in the middle of both the things. So we will try to find the accuracy by giving the feedback, and we will enhance the accuracy. So that is what happened in the semi-supervised learning, and this is what very popular in machine learning. Then automatic methods of collecting data make it more important than ever to develop methods to make use of unlabeled data. Then we'll talk about supervised learning. When we talk about supervised learning, we have two things. One is analogical learning, another one is learning by decision tree. So analogical learning, it is an instance of a problem, and the learners has to form a concept that supports most of the positive and no negative instances. This demonstrates that a number of training instances are required to form a concept in inductive learning. Unlike this, analytical learning can be accomplished from a single example. For instance, give the following training instance, one has to determine the plural form of bacillus. So problem instant is we are giving input, and expected output is plural. For example, suppose I am giving fungus, the possible output is fungi. So something like that we can have. So what are the steps involved in analogical learning for now? Means we'll see one by one. First one is identifying analogy. Identifying the similarity between an experienced problem instance and new problem. Determining the mapping function. So relevant part of the experienced problem are selected and the mapping is determined, and finally applying the mapping function. So applying the mapping function to transform the new problem from the given domain to the target domain. So these are the steps, especially identifying analogy, determining the mapping function, then applying the mapping function. So once these three major areas over we can go for the validation and learning. So validation means the newly constructed solution is validated for its applicability through its trial process, like theorem or simulation. Learning, if the validation is found to work well, the new knowledge is encoded and saved for future usage. So whatever I explained, that is depicted in the diagram. So singular form fungus we are giving, new instance bacillus. So the plural is bacilli, right? So last two letter we are having us. So what we can do is already existing data set we are referring and detect similarity. So we are replacing this as with I, and so we are getting the fungi. Okay, so this is the way we can do the learning. So that is one type of supervised learning, and another one is learning by decision tree. A decision tree reveals a set of attributes or properties of the objects as input and yield a binary decision of true or false values as output. Decision trees thus generally represent Boolean function. Boolean means what? 0 or 1 or yes or no, right? So beside a range of 0 or 1, other non-binary ranges of output also are allowed here. However, for the sake of simplicity, we presume the restriction to Boolean outputs. Each node in a decision tree represents a test of some attributes of the instance, and each branch descending from the node, that particular node, correspond to one of the possible values for this attribute. So we will learn by taking proper decision with the help of a decision tree. To illustrate the contribution of a decision tree, we consider set of instances, some of which results in a true value for the decision. Those instances are called positive instances. Suppose the result decision tree is a false, means we can take it as a negative instance because it's a combination of positive and negative instances. We now consider the learning problem of a bird's flying. Suppose the child sees different instances of bird, what is the thing will happen? See, definitely different instances we'll see number of wings, broken wings, it's whether it is alive or dead, then wing area, weight of the bird. So these are the various attributes. Based on that, we can determine the flying condition. Okay, definitely living status is a major thing. If the living status is dead wing, definitely we can say that flying condition is false. So it should be alive, right? Then if it is a very heavy wave, means it won't what? It won't fly. Similarly, there is a broken wing and two wings are broken wing, definitely it can't fly. One means there is a possibility, zero means there is a heavy chance of flying. The number of wings, zero means it can't fly, right? So like this, we can have a data set, based on that we can go for the conclusion. So that is learning by decision tree. So how exactly we are formulating a rule here? It is seen from the above table that fly equal to true if number of wings equal to 2 and broken wings equal to 0 and living status equal to alive and wing area or weight of the bat should be greater than or equal to 2.5 is true. So this is the final correlate rule we are writing. So this is a decision tree example. So that is actually explained in another one slide with more explanation. Now we'll focus on the applications of machine learning. So drug discovery, definitely with the data set, we have repeated training, we can able to find accurate solutions, which in turn able to create some new drug discovery. Then medical diagnostics, the early detection of diseases like cancer and all that we can do. Then iris verification for security purpose. Then handwritten digits to convert into a normal digit. Then these are examples of radar image exploration, speech recognition, especially fingerprint recognition, signature verification, face recognition, target recognition. It's like an army and all, the target is hidden, then we can try to do. Then robotic vision, then traffic monitoring. These are the some of the example of machine learning. So in day-to-day life, in real world, everywhere we can apply this machine learning concept and we can able to do automatic things so that our life become easier. Thank you for watching. Thank you.